Good morning. Today we are going to discuss about load distribution schedule. Experienced professionals might be already familiar with different types of load distribution schedules, but for the less experienced guys and also for the freshers, this will be useful. So let us see how a load distribution schedule looks like and also explain the different details inside a load distribution schedule. So the standard format of load distribution schedule is looking like this. It is a load distribution schedule of a single phase distribution board, and we can call it as DB schedule also. Then this is the standard format for a three phase distribution board. Okay, so like different columns are there. These are the standard formats for both the single phase and three phase distribution boards. So the same format, it is included in the 2017 edition of DEVA regulations. So what is this load distribution schedule? It's a table which is consisting of all the details of the circuits which are connected with a distribution board. So using a distribution board, power is distributed into different circuits and in each circuit different loads are being connected. So by this load distribution schedule, let us represent all the details of that circuits and also the loads which are connected inside that circuits. So the rating of that different loads, so the total power of each circuit, then the circuit breaker rating, then the main circuit breaker rating, cable size, main cable size, total load, etc. Let us go to a real life project and its load distribution schedule. So this is a real load distribution schedule. You can see different details are filled inside this. So this table will be consisting of all these details. So load distribution schedule we have to submit along with the other drawing documents for getting the approval. So like load distribution schedule, using this load distribution schedule, we can make the single line diagram. Let us balance the load between the three phases. Here you can see like three phases are there. For a three phase load distribution schedule, we have to balance the load between the three phases R, Y and B. So with the help of a load distribution schedule, easily we can balance the load between these three phases. And also this load distribution schedule will be showing us the route of that, the route of the distribution of the power. Route of the power distribution. So like here you can see like the power is coming from this part, then it is going to like these circuits. So with the help of this load distribution schedule, it will be easier for making a single line diagram also. Then let us select that cable size, circuit breaker size, etc. with the help of load distribution schedule. So here I'll be explaining each details about this load distribution schedule. That is each columns of this load distribution schedule. Like here you can see it is a three-phase distribution board, and the project name I have made it hidden. Like you can include your project name here, DB number here, and like from where the connection is, like here it is coming from the SMDB. Here is an existing SMDB. So from the existing SMDB, the connection to this final DB is coming. So like you can call it as a DB schedule also, because it is showing the details of the DB, right? So like the load details of the DB. So we can call it as a load distribution schedule as well as a DB schedule. Like inside an electrical system, like each DB and electrical panels will be having a load distribution schedule. So here, while looking at this load distribution schedule, like you can include the location of this DB. Okay, then here is the first column, that is a rating of incomer. A rating of incomer means like the main isolator or main circuit breaker of a DB. Here 125 ampere TPN isolator is used. So how to size this isolator I will explain at last. Then the next column is about rating of ELCB, that is earth leakage circuit breaker. Then Serial number of each circuits are given here. Then circuit numbers are here like R1, Y1, B1, etc. Since it's a three-phase distribution board, like three phases are used alternately like R1, Y1, B1. Like that, we are including the circuit numbers in a load distribution schedule, three-phase load distribution schedule. Then MCB rating is here. Then like CCT wire, you can see there. CCT means circuit current transfer wire. Then ECC. This is actually ECC, not RCC. It is ECC. ECC is earth continuity conductor. In the standard format of that, you can see there ECC, CCT and ECC, earth continuity conductor. So both wire size can be given here. That is a phase wire size and also the earthing wire size. Then next column is about room or area. That is the location of each circuit. So for R1, the location is the counter area. Okay. Then the next part is that connected load or points. Connected load or points means whatever loads you are connecting with this DB, all that load details you have to include here. So like this will be different for different DBs because like for each DB we will be connecting different types of loads. So whatever loads you are going to connect with your DB, that load details you have to include in this section. So lighting is there. So for this DB, you can see there like lighting is there. Then lighting in meter means strip light will be there, strip lights. If you are having strip light, that lighting we are measuring in meters. Its length is measured, right? For others type of light fittings, we are measuring that in count, number. So the numbers can be included here. That strip light length can be included here. Then 13 ampere SSO, that is switched socket outlet is included. 13 ampere SO, that is single outlet. 13 ampere TO, that is twin outlet. Then WH water heater is there. Then spur outlet is included. FCU is included. Then isolator is included. Okay, then if you are having any other loads, that can be included in this column. So this part, whatever loads you are connecting with the DB, that details, that load details you have to include here. Then per load. Next column is per load in watts. That is for each of these electrical points, how much load is considered. For example, here we are having 6 number of lights. For each light point, how much load is considered. So here for each lighting point, 100 watt is considered. So that is included here. That is load per load. That is the per load column. Then the next section, we are dividing that load per 3 phases. So here it is R1. So that load, total load will be coming under the R phase. If it is Y1, then that load will be coming under the Y section. So like equally 3 columns are made R, Y, B. So each R1, R2, R3, that all loads we need to include under R section. Then all that Y loads we need to include under Y. Then all the B1, B2, B3, etc. we have to include under B phase. So like per load, here you can see 100 watts per point, right? So that 6 into 100, 600 is the total load of R1 circuit that has to be included under R phase. If we are going to the respective drawing of this, let us find out these different circuits. So I am going to the drawing. So like we are having different drawings regarding with this, like lighting drawing will be there, lighting layout is there, fire alarm layout is there, power layout will be there, then emergency lighting layout will be there. So I am just going to that lighting layout so that you can see all that lighting circuits in that drawing. So it is a proposed lighting layout. There you can see like different types of lights are used. So like in the legend, you can find out different types of lights are being used in this. L1, L2, L3, L4 like that. So here different circuits are shown. R1, Y1, etc. For example, here you can see like here is R1. R1 is here. So in this R1, that L5 type of lights are connected. So like R1, that dB number is specified here. In R1, that dB number, the circuit is R1, then 6 number of L5 type of lights are being connected. So for each L5, you can find out the watts from here. L5, how much is the watts? That you can find out from the legend here. So we are going to that load distribution schedule again. There you can find out that R1, first circuit, 6 number of lights are connected here. Then 6 into 100, that is 600 watts. Same like let us check for the Y1 now. So Y1 we can find out like R1. Here is Y1. At the top you can see there Y1. So this is the Y1 circuit. Y1 is here. 10 number of lighting points are connected, like L4 type of light fittings are connected in this Y1 circuit. So if you are going to that load distribution schedule again, here is Y1, the second circuit is Y1, then it is in counter area, then it is having 10 number of light fittings, then it is having 24 watts per load, then 24 into 10, 240. Like that, we are including the details of each circuit in this load distribution schedule. So after designing and making that layout, we have to prepare this load distribution schedule. So for each circuit, the load details and its circuit details and the load details we have to include in this load distribution schedule. Like that, similarly, B1, R2, Y2, B2, for each circuit from the drawing, we have to include the details in this load distribution schedule. Then after calculating the total load in a circuit, we have to select the size of MCB, corresponding MCB. Here for the R1 circuit, the total load is 600 watts. Then we are selecting 10 ampere MCB. Then for same like second circuit, Y1, 240 watts is there. Then we have to select same 10 ampere, because for the lighting circuit for commercial applications, mostly we are using 10 ampere MCB. Then the cable size or the wire size here 2.5 mm square, ECC also selected as 2.5 mm square, because for the lighting circuit the minimum size of wire that we are using is 2.5 mm square as per DEVA regulations. So when we are coming to downwards, like here sockets are included, then the like MCB size is changing here, cable size is changing, because here there are circuits including sockets. So for all these lighting circuits, 10 ampere MCBs are used, and that cable size is used as 2.5 mm square, because for the lighting circuit we are having regulations like that. Then for that power circuits or for the circuits which are connecting sockets, here you can see that MCB size is changing as 20 ampere. For radial circuits, we can use 20 ampere MCB. For ring circuits, we can use 32 ampere MCB. After including the details of each circuit, finally, we are calculating the total load. Based on this total load, we are selecting that main isolator or the incomer size and also the main cable size. So while distributing the loads, finally, when you are checking that loads in the three phases, this should be balanced. Like in R phase, Y phase and B phase, this should be balanced. The loads should be balanced. Here you can see it is balanced. Like in R phase, 20.35 or maximum load is, total load is 60. So per each phase we have to maintain approximately 60 by 3, 20 kilowatt. Perfectly we cannot divide that into equally 3. But approximately we have to do that, like we are getting approximately 20 kilowatt load in 3 phases, each phases. So while balancing this, up to 10% unbalancing can be neglected, but more than 10% is not recommended. It will be causing voltage problems, like voltage fluctuations may be happening there. So we have to balance the load between the 3 phases. Okay, now the total load we are getting is 60 kilowatt. Then as per this load, we have to calculate the load current. Then how to calculate the load current? For calculating the load current, like power equation we are having for single phase and 3 phase circuits, we are having the power equation. So if you want to make a load current calculation, we have to use the equation for that power. For power calculation, for single phase, we are using P equal to VI cos phi. For 3 phase, we are using root 3 VI cos phi. So this is a 3 phase load distribution schedule. So here I have to calculate the load current for the 3 phase. So like what is the power equation, like power in watts, actually it is root 3 VI cos phi. Then power in kilowatts, because the actual total load we are getting in kilowatts as per that load distribution schedule. So we have to form an equation for the load in kilowatts. So like it is root 3 into VI cos phi, simply dividing that with 1000, converting watts into kilowatts. Then current, we need to calculate the load current. So the load current equal to load in kilowatt into 1000 divided by root 3 V cos phi. So here I am considering that voltage as the standard voltage, because the supply voltage of each country will be different. For Dubai, we are using that supply voltage that we are getting is about 400 volt. So root 3 into voltage 400, that is a 3 phase voltage. Then for single phase, it is 230 volt. Root 3 into 400 into cos phi. For optimum efficiency, I am considering that as 0.9. Now let us calculate this. So we are getting that answer as, just calculate, root 3, that is 1.73 into 400 supply voltage into power factor 0.9, 622.8. That is a denominator. Then let us divide that factor with numerator, that is 1000. So it is about 1.6056. See that supply voltage, for the supply voltage 400 volt, we are getting this factor. If the supply voltage is something different, for India, we are considering 415 volt. So it will be different. It will be about 1.54. When you are calculating using the different parameters, that is the voltage will be different there. Then you will be getting a different factor. For each voltage, this factor can be different. So here it is 1.6. As per our voltage, we are getting 1.6. So let us calculate the load current with the help of this factor. That is like load current, we are getting 1.6 here. And now we need to calculate that size of this isolator, then also the cable, right? So 1.6 factor, I am considering 1.6 into, what is the total load in kilowatt here? It is 60 kilowatt into safety factor 20% I am adding for the future expansion. For the safety reasons, I am adding 20% extra of the load. It is called a safety factor 1.2. So I am getting 115.2 ampere. So the load current I have calculated by using the equation, that is 1.6 into 60. Then 20% extra safety factor also I have considered. So I am getting 115.2. So as per this value from the table which is given in DEVA regulations, let us select the cable size as well as the isolator size or the breaker size. So we are having a table which is given inside DEVA regulations. There you can see breaker size, cable size, and also ECC size as per DEVA standards. So here we are getting 115 ampere. So after 100 ampere from this table, 125 is available. So we have to select the nearest higher value, that is 125 ampere. Then the corresponding cable size is 4 core 50 mm square. Corresponding ECC size, that is the earth continuity conductor, is 1 core 25 mm square. So we can select this breaker or isolator and also these two cables. Main cable 4 core 50 mm square, ECC as 1 core 25 mm square. So that is why we are using that isolator here as, see, it is 125 ampere. TPN isolator, because TPN is used because it is a 3-phase load distribution schedule. So for the 3-phase, that main isolator or the incomer will be TPN or 4-pole. It is 125 ampere TPN isolator. Then the cable size is 4 core 50 mm square with 25 mm square, 1 core 25 mm square ECC, earth continuity conductor. So this is how we are including the details of our electrical project in a load distribution schedule like this. So this is the load distribution schedule of a final DB. Like this, we will be having load distribution schedule for each of the DBs like SMDBs, MDBs, etc.